Okay, welcome to my TED Talk. So obviously this is an OpenPLC project, a very simple traffic light project. And essentially what I'm just trying to do here is show you what a step engine Boolean array matrix looks like. Okay, so that's what this is essentially. This code here is a step engine in the form of a Boolean array matrix. Okay, some of you might not know what that is. But I'll walk you through it and explain how it executes, so on and so forth. Before I kick off, if you have downloaded this code, the first thing you want to do is go to the project tab there, and normally you go straight to the config variables. Okay, we actually want to come to this config, the one that I've highlighted in blue here, and I have done it in Windows 32. So if you're using, say, Ubuntu or some sort of Debian, Kali, whatever you like in Linux to run your engineering environment, you'll have to switch this project to like a Linux target type. Otherwise, you'll end up getting compilation errors. Okay, so if you're using Windows, great. That's what this project's set to by default. If you're not using a Windows engineering environment, then you'll need to come in and change this. Okay. Back to the code itself, I'll come over here to the debug screen. Now, this PLC code is a bit of a holy war discussion. What do I mean by that is that if you grab, a few PLC engineers by trade, they may look at this code and then start swearing profusely. It's, I wouldn't say an acquired taste, but Boolean array step engine matrix has been around since like the early 90s. And if you, for example, look at the traditional way that we do step engines, right? Or just control PLC ladder logic, we generally have the standard is equal. So these are the is equal blocks. So is your step number, say, equal to 2, equal to 3, equal to 4, and I'll say that the actual number is number 1. Okay, so that's our actual value, right? And then we're comparing it to see, hey, are you actually equal to step 2? And if so, execute these sort of way to look at it, the function blocks themselves. We do a comparison. Are you equal to this step number? If you are, execute this code here. Essentially, that's what we're doing. And so when you look at it, it's sort of like, okay, are you equal to, is 1 equal to 2? Compute processing, yes, no, right? It's going to be a no. Obviously, the same thing. Are you equal to 3? Compute processing, so on and so forth. Nope. And then are you equal to step 4? No. If we did have the actual value for the step number was 4, then this is the only one that would execute, only this line. All right. Basic ladder logic terminology. What a Boolean array does is it sort of pre-populates all that sort of information. And instead of are you equal to, it's, sorry, let me just draw some back. It's basically a you contact, and you're basically saying that this is step 1, this is step 2, this is step 3, and step 4. Okay, and they're all the Boolean symbol contact. Right, so instead of are you equal to, that's probably almost unreadable now. So I'll use step 1, for example. It's like I use step 1, off on, true or false. And if this Boolean thing is on, then this code will execute. So the computation is a lot faster. That's why we program this way, essentially. All right. Now, another thing is that this is non-discrete step engine. Generally speaking, the step engine is sort of like the first 3 rungs. So this probably that's a rung, that's another rung, that's another rung. That's RUNG. So 1, 2, 3. That we'd probably actually create a custom function block, and then as would validate that custom function block that it executes correctly, and then we'd probably just use that, and then we'd have inputs and output parameters. So for the computer science people, it's just a function. You pass variables in and variables get passed out. Right? That's basically it. But now I'll explain how it functions. Right, so the first thing we're going to do is do a boundary check. Right, this is not a cybersecurity thing. If your number goes out of the array index, you will fault the PLC and you'll DOS the process that you're controlling. Right now, you don't know this, but my array has got a maximum of 15. You can see there, 15. They're all set to 15, 15, 15. Now I've put 10 in here just to show you that you don't have to do 15. I only need a maximum of 10 steps, so that's why I've got 10. Technically, it's 11 steps because 0 is still a step, so that's 11 possible values, 11 possible steps. And the first thing we're going to do is then turn off the current bit. So whatever bit is active, we want to turn it off, right? This will make more sense later, but what we're doing is I want nothing turned on, and then later, once we've gone through all our things, I'm going to turn on the current step number. Okay, so we've got step active there, and then whatever the number is that we've set it to, all right? And then step active, all right, turn it off based on that number. So this executes really, really fast, and then by the time we get down to here, we will have a bit active, and there will only be one bit in the array turned on, okay? So that's why we do it, all right? So that's the first thing we do. Otherwise, what could happen is the array where we have, I'll just draw it. So in the array, we'll have 0, 0, 0. So that's 0, 1, and 2. And then we'll say step 3 is on. That will be a 1. And then the rest are zeros. Okay, I might actually switch to type text. Now, if we don't turn it off at the start, what happens is when we move steps, it will be 1, and then 1, and 1, and 1, and 1, and 1, and 1. And then basically they're all on. Okay, that's typical execution. So we have to remove the on thing right at the start, and we'll still use bit 3. So once the code executes, we'll basically turn it back on within like 5 milliseconds, okay, before any of the remainder logic is executed. So that's essentially what we've got there. So boundary checks, turn that off. If we go out of bounds, we basically move to step 0. All right. Now, the second rung here is checking if we've got a change. So we've got our current step number. So this is what we are looking at. And then maybe conditions have changed and we've got a step request. So we're saying is if the step number and the step request are different, i.e. someone wants to change the step number based on the code, then execute, okay? So then we've got a write trigger, which is like a one-shot, meaning it only executes once per scan, and it will stay true until those conditions aren't met anymore. All right, meaning like you could be in this rung for like, I don't know, 5 seconds, but it is only going to execute once, hence the name one-shot. Okay, so this is the output of the one-shot. We're going to move the step request number into the step number, and then we're going to move the step request, step timers based on the step number into the pretext of the step timer. The step timer is just below here, which we're going to have a look. So what that means is, again, say we're step 3, right? That's our current step number, or it's just changed to step 3, I should say. What we're going to do is we're going to come up to the timer here. You can see it's an array of time instead of bool. And so that would be 0, that would be 1, that would be 2, and that would be 3. And so what that's going to do is it's going to move the 4 seconds into the preset, okay? If this were to change to, say, randomly, just change to a color here, step 7, so step 7 is our new number that just happened to happen, then we'll go all the way across 0, 1, 2, 3, 4, let me guess, I managed to pick a number outside the array, 6, oh, just in 7. Okay, so now what's going to happen is instead of 4, it's now going to be 3 seconds. Okay, that's just how the array sort of works. That's what those squares represent. So up here, it's the indexing. So in this example, in orange, our step active is going to be bit number 7. All right. Cool. So now that that has executed, If the timer isn't paused, you can enable it. If the timer hasn't run out, then that's the input variable. Our preset is set by this, so we don't need to do anything there. And then the timer is just going to keep, as long as it's not paused, it's just going to keep executing, i.e. it's going to count up, essentially. And then we're just converting this unit to the timer elapsed, okay? And then finally, we enable our step active bit here. Okay, once again, like in the orange example, we said step number 7. So step active number 7 is what's going to be on. So again, this is our array. Okay, sequence 01, step active. And then, you know, you'd count the bits 1, 2, 3, 0, 1, 2, 3, 4, 5, 6. And number 7 is the only thing on. So that would look like this in the array. It'd be 0, 1, 2, 3, 4, 5, 6, and then 7 would be 1, and then the rest would be 0. So on and so forth, right? So now only that bit is executed. And so if it was step 7, this would be off. This would be off, but this is step 7. And so that would be on. And so this rung would execute. And if the conditions were met, where the north-south traffic light was red and the east-west traffic light was red and the timer had completed, then we're going to move step number 2 into the step request. So now we've got 2 in the step request. So our step number is, and switch back to orange. So our step number is 7. And then our step request is now 2. So if you remember up above, we can't see it now, but up above here, there was a not equal. Well, these are no longer equal. All right, so let's scroll back up there. I have to clear the screen, sorry. So if you recall, this was 2 and this was 7. And so they're no longer equal. We're going to trigger our one shot. We're going to move 7 into, sorry, 2. That's incorrect. We're going to move 2 into the step number. So now the step number is going to be 2, and then we're going to move that preset into the timer. And then now we're looking at step number 2. So now this will be active. And then north-south will be red, east-west will be green, the step timer will complete, and then we'll move to the condition of 3. So step request is now 3, so on and so forth, okay? So that is our transition steps. Where you see step active, those are all our transition steps. All right, what about controlling outputs? This one here is just moving 0 if we ever get to step 10 or someone hits the stop button, which we don't actually have. So once again, we've got an array here. All right, so there's the indexing. So what we're looking for is whatever the step number is. So if we were to go back a couple of steps and reuse our step 7 sequence. Okay, so our step number is 7. So now we need to look at this array and find out what is step 7. And you can see that this is this one here. Right, so very, very hard to read, but that's 0, 1, 2, 3, 4, 5, 6, 7. So 7 would turn this output on, right? But if we move to step 8, then this would go off. And then 9, 10, 11, 12, 13, 14, 15, all off, okay? This one's pretty simple. This is not an array. This is saying step 6, your north-south light is amber. I happen to have orange on, so that's useful. We scroll down a bit more here now, and we'll see that north-south is green only on step 5. We go to east-west, red, we've got another array. So same thing, right? Our example was, I should use red. So we were using 7 as an example. We're in step 7. And we look at the array here. And then we've got 0. That's 0, that's 1, 2, 3, 4, 5, 6, 7. So in step 7, this is also on. Okay, Step 8, it's off. In fact, well, we've got 7, 6, 5, 4. So basically from step 4 to 7, it's on, and it's also on step 0 and 1. Okay, for the east-west traffic. And that's how you read that. And then these are simple, step 3. So you can do complicated arrays, or you can just, you know, add a branch, add a wire segment, or, you know, basically you branch it out like that, have a number of contacts, maybe step 4, and then this will be on step 3 or 4. Okay, you can do it that way as well if this is too complicated for you. So would I use this step engine in production? No, this is too complicated here. You can see how hard it is to count out the dots. What typically happens in a lot of professional PLC programs, you know, stuff you pay for, there's usually like a plus icon, and then you get access to all the bits, meaning like, you know, sequence EW red .0 is this line, and then .1, .2, .3, so on and so forth. And then you could put comments here. OpenPLC doesn't allow you to do that, which is why this gets a bit horrible to maintain. But for the purpose of creating like a lab to stick a process in, you've got this basic step engine that you can go for. If there's enough requests for me to create like a simple boiler program, I can do that, and then you can draw it yourself on any HMI that you like, and then you could use that process code. But I thought I'd give you a bare bones step engine, and at least you could go from there, see what it looks like. Another thing is if we do some simulation, sorry, that was the simulate button there. And then I come across to here. One thing you'll notice is, you know, we're green, this is executing, this code isn't executing. Should probably change my line drawing. So I'll switch to a different rung so it's simpler. Now you can see that the timers are counting, and you can see the timer there is going into an integer. So you know this is working, right? I can see that the step request is step 5 there, and the step number is 5. And after a period of time, you'll see that change. Now, what's interesting about monitoring in OpenPLC is that the production team, I'm not criticizing them, but they've clearly never worked with a step engine Boolean array or matrix, because this stuff doesn't execute. You can see here, oh, it just changed on me. This one was just active a second ago, and it doesn't look like it's actually executing. So if I scroll up here, I happen to know that this will be the step active because they're both on. And so we're waiting for the timer, then it will switch to step 3. Okay, there you go, step 3. It's cycling through, but you're not seeing the green lines. If I come up to the top here, it's very easy to see which lines are executing because they're completely green, like that. Okay. Hopefully that's explained everything to you. Like I said, it's a bare bones step engine, so you can program a process that you like. If this is not your forte, that's fine. If you'd like me to create an actual process, just let me know which process you want me to draw up in OpenPLC. I hope you've enjoyed this talk.